A life insurance policy pays 1,000 upon death of a policyholder, provided the policyholder survives at least 1 year, but less than 5 years after purchasing the policy. Let X denote the number of years that policyholder survives after purchasing the policy with the following probabilities. Calculate the standard deviation of the payment made under this policy. So the probabilities are not given for X is equal to X, but for X less than X. So for example, the first probability is that the policyholder survives less than 1 year. And the second probability is that the policyholder survives less than 2 years. Okay, so on. And we have to find the standard deviation of the payment made under this policy. So I call Y as the payment, and a payment of 1,000 happens if the X is between 1 and 5. Remember, X was the number of years that the policyholder survives after purchasing the policy. And we are told that the payment of 1,000 happens only if he survives at least 1 year, which means X is greater than or equal to 1, but less than 5 years, which means less than 5. So greater than or equal to 1 and less than 5. So that's why we have a payment of 1,000 when X is greater than or equal to 1 and less than 5, and no payment happens otherwise. So from the given table, as I briefly mentioned, the probability X less than 1 is 0.05, and probability X greater than or equal to 5 by our fundamental laws of probability would be 1 minus probability X less than 5. And we are given that probability of X less than 5, that's the last entry, that's 0.48. So it's 1 minus 0.48, so that's 0.52. So that's the probability X greater than or equal to 5. So you see, less than 1 and greater than or equal to 5 basically take care of everything that's not in this range, greater than or equal to 1 and less than 5. And so now we know that when X is less than 1 or greater than or equal to 5, the probability of that part is this 0.05, that's for less than 1, and the 0.52, that's for greater than or equal to 5. So that probability is 0.57. And therefore, this will give the probability of X between 1 and 5, which is the complement of the previous row. So that would be 1 minus the probability of the previous row, which is 0.57. And so 1 minus 0.57 gives us 0.43. So the payment under the condition that X less than 1 or greater than or equal to 5 is 0. And the payment under the condition that it's greater than or equal to 1 and less than 5 is 1,000, as given. So next column is payment times the probability. Remember, we are finding the expected payment. So that will be the summation of the payment times the probability of each payment. So YP is 0. And YP is 0 when P is 0, and YP is 430 when P is 0.43 and payment is 1,000. And then for the expected value of Y square, we need the Y square column. Remember, the eventual goal is to find the standard deviation of the payment. So we'll be needing expected value of the payment and the expected value of the payment squared for that. So Y square, we squared the Y column, so 0, and then 1,000 squared is 1,000,000, and then we need the Y square P so that we can sum up to find the E of Y square. So Y square P is 0 for the first entry and 430,000 for the second entry. So expected value of Y is the summation of YPs, which we see to be 430. And the expected value of Y square would be the summation of Y square times the probability. That's 430,000. And so the standard deviation of y is the square root of e of y squared minus ey whole square, our standard formula. And that ends up being 495. That is choice D.